All right, let's go. It's learning time. Lock that shit in the brain. No pussying out. Let's get it. Prompt action, please. Quizman, everything covered in. Okay. $20. Oh, not. Oh, not multiple choice. Yo, not multiple choice. Jesus. Ah! It went from 20 questions to 400. Holy Lord. Okay, wait, that's it? What? Okay. Alright. What's required to compile? I mean, it seems like we just need a main function, right? What else is needed? I mean, main automatically returns 0. Oh, I fucked it. Anything else I'm missing seems like it's already included in the compiler. I mean, it seems like it's just a main function. I don't remember what exactly calls main. Main is called by something, so it's declared, but it needs to be defined. Otherwise, we get a linker error. C++ programs have a main function, from which all logic is called. Other logic might exist in other .cpp files or be included in them from header.h files, but that logic is still initially called from main, because a CPP file might call other shit within, but it's called from main, and everything eventually returns to end. Control eventually returns to main as the call stack pops calls off, as calls are popped off the stack. A main function is required because main is declared in the executable. A definition compilation will yield a linker error because the declaration exists, but no definition. Okay. Single line, multi-line comments. Single line. Why are comments important? They make comments make understanding code easier if used properly. Making code handoffs easier. And I think so. Okay. Variable is an object. Okay. How do we declare a variable? Okay. Cool. Cool. the fuck happened here? Okay. 6. Undefined behavior is behavior that isn't defined by the C++ standard, i.e. what value a, or well, yeah, sure. C++ standard doesn't say what value an uninitial, or what value a variable should get when declared but uninitialized. Some implementations, IDEs, or some compilers might assign the, or might give the variable 0 or value, depending on type, but others might not. I.e., if we use it without initializing it, we don't know what value we'll get, and thus behavior is unpredictable and undefined. We should assume the variable uninitialized variable has a garbage value. Whatever value was in that spot of in memory before, or well, yeah, at the time of instantiation. Cool. 7. Keywords are words reserved by C++ for specific features. These include data types, and not functions, and okay. Cool. And then I have to say rules for naming objects. Or well, actually, will it do that? Oh, it'll interpret it as a suffix. Another, so no operators, none of that. What else? Can't lead with a number. No operator, or no operators inside. What else? So now, no to something, no something minus something. Can't think of any more right now. Rules. That's camel case is style. The suffix stuff doesn't help either. So yeah, no operands, no numbers in the beginning. Like, how do I fuck up on it? And no, that's an operator. That's a number. Can't use a keyword for an identifier. Maybe? I think so. Alright. Well, yeah, keyword is a data type. Okay. White space improves readability. I mean, seems like that's the whole point. Seems like that's the point, readability. Okay, what else? Different types of literals and basic operators? What are you talking about? Different types of literals and basic operators? Okay. What else? An expression. An expression evaluates to a result. A statement is, that ends in a semicolon. Serves. Outline the steps to develop, compile, and run your C++ program. Okay, what else? I mean, compiling is simple. You just fucking compile. Hello? Hold on. or an interpreted language. For interpreted languages, isn't it the whole thing is converted into binary versus what? Converting it into, isn't there like some sort of intermediate step? Um, so how do interpreted languages work? Isn't line by line being interpreted into, isn't it? I think. I could be wrong. All right. Okay. Cool. 59. All right. So we could say okay. So we could say const expression in force Cool. 58. Return compiled cause expression values. If called in a context where the return value must be known at compile time. Usually this is when call me function to initialize a const expression variable, because const expression variables must be initialized by const expression initializers. Okay, 57. If we have a function template with multiple template types. Hold on. A template type? Hold on, the terminology here. So if we have some code coverage action, some other stuff, auto keyword type deduction, function templates to generate, or for as generic programming to generate template functions that are instances that do the same shit but for different parameters. That way we don't have to make a bunch of different overloads manually or specializations manually. How do I use a function template with multiple template types? I mean, I'm interpreting the template type as being X and Y here. So like a type name T, type name U. Assuming you mean well, hold on. Type template, isn't it called a template parameter? A template type parameter? A function template with multiple template types. Multiple template types. Seems like that's the different version of the function. By template type, if you mean an individual function instance, template function instance, we can explicitly template type parameter Okay. Okay. Function templates let us create multiple versions of functions to with different parameter types and counts. We'll say types, because if I do the template and it has two type names, then all the pieces, all the instantiations would have to have two arguments in the call. Okay, 55. Okay. Auto type deduction. What do I think about it? I don't really like it that much. Okay. I think, is it test as double? Yeah. Yeah, I screwed up because we're using test. Cool. $51. Oh wait, that was 51. 52. Narrowing conversions are when we're converting data of one type to another type, and the second type can't represent all values of the first type. Oh, it's too fucking hot. Why? Maybe because I'm locked in and using my brain. Let's go. Getting tired of this song. Have a drink water in a sec too. Okay. How do we prevent narrowing conversions? By using smart implicit conversions with awareness of what conversions will happen, or by using explicit, what do we use explicit conversions? If I use an explicit conversion to convert a float to an int, the fuck? Cool. 50. Assert. Checks its calls standard abort if its condition is false at runtime. Static assert does the same at compile time and requires a compile time condition. Static assert lets us check. What is static assert helpful for? I mean, right now I don't find static assert to be very useful. I mean, we could have a constexpr function and use static asserts in it to test some stuff. Cool. Cool. What are we checking here to see if if cool. Okay, 47. What else? We can break out of a loop and I guess a switch. That's kind of it, huh? Cool. Wait, uniform distribution. Hmm. Okay. So we use switch statements when we have a specific value we want to switch on, or switch with, switch on, I guess. Switch via, something like that. And we're going to check it for very specific values. If it's for a die, we say for 1, 2, 3, 4, and 5, do nothing. But on 6, bam! That's where the bullet is. So we have case 1, 2, 3, 4, 5, nothing. Or, do nothing. Null statement. Break. But for case 6, bam! Oh, but then maybe we have to update the case. Or, how would that even work? At some point I want to make Liar's Bar in code. The game where people have cards and they put in a certain number of cards and you have to guess whether they're telling the truth or not. Oh, did he put down 3 cards. Were they actually 3 kings or is he bullshitting? Did he put in 2 queens? That way the next hand he can put all the kings in and actually be safe. Well, I'm gonna have to do a dice roll. I mean, in that case, but yeah, so if he does a dice roll and it's 3, I could say we'd have to have a switch case. The problem is if I had a switch on the dice roll, the first time he calls it, 6 would be, if he rolled a 6, that someone calls liar on him, and he's lying, and he has to shoot himself. Well, if he rolls a 6, we want him to shoot himself. So we have 1 through 5 cases, 1, 2, 3, 4, 5. Have a null statement, doesn't do anything, or it does the click, and then break. That way he doesn't also shoot himself. And then for case 6, shoots himself, break, or return, whatever. But after he shoots, then we want 5, or if he shot and it wasn't a click, now we want 5 and 6. Or hold on. Now we want him to, we actually just want to restrict the range. So 6 is where the bullet is. It's just that he shot once, so he only has 5 shots left. 4, 3, 2, 1. So what we would actually do is just call, the chances are the same. If you roll 6, you'll lose. If you roll something else, you're good. But we just restrict the standard uniform distribution, or standard uniform int distribution. That way, we call it once from 1 to 6. We call it again from 2 to 6, 3 to 6, 4 to 6. And then finally, you've shot 4 times. You only have 2 shots left over, and one of them's the bullet. Now we only call it from 5 to 6. It's 50-50. It's either 5 or it's 6. It still hits the switch case the same. The case is still the same. If you get 5, click. If you get 6, bam! So, that's how we do it. Let us compare the value of one variable, one integral type variable, bool character int specific case values, each of which may have its own logic, or multiple cases can share logic, i.e. maybe dice rolls 1 through 5 all call click and break after to avoid fall through to case 6, while case 6 calls bang and break, since 6 was the bullet roll in the revolver. If statements are good for checking ranges, but if we know all the possible, if we ranges, like if we want logic to trigger if x is greater than something, or if less than something, but switch cases are more convenient for checking specific values. We still have default to check to execute code for execute logic for any other value, any non-case value. We could still do a bunch of else if x equals y statements. They switch cases cleaner. Instead doing case 1, case 2, etc. Okay. While loops only execute if the condition is true, and the condition is executed before any inside code. Do while loop executes the loop first, then the condition, so it executes at least once. For loops execute after checking a condition and are more convenient since they can put variables in there. What is the for loops line called that includes the variable initialization, definition, the condition, and the post logic update part? Tell me. Please tell me. Okay. Component statements let us execute statements in execute multiple statements in their own block of scope. That way we can use identifiers there without conflicting with identifiers elsewhere, or well, without later identifiers conflicting with this block's identifiers. Defined identifiers. Easy. Lets us compartmentalize code. Next. Multiple statements after different switch cases or if statements. Cool. A global constant. I'd define inline const expression constants in a header file and include it in all needed .cpp files. This lets us have the linker deduplicate the multiple definitions to only use one spot in memory for the variable, while letting the compiler perform maximum optimization because the constant is evaluatable, or is a compile time constant. 41. Variable shadowing is when an inner variable with the same identifier as an outer variable is prioritized in calls by the compiler. Or rather, we could say when the compiler prioritizes calls of an inner variable over an outer variable when they use the same identifier, i.e., if x is defined outside our block, but x is defined again in our block, it's fine since they're different scope, but we might need to use the scope resolution operator to access the outer x. We might want to identifiers if both are in our local variables, because there wouldn't be a way to call the outer x. Meaning in main, void do thing, sure. I keep on doing that. Void do thing, like that. And then we'll just say in x is 3, and then in x is 2, and then we need standard character output because we want to print these guys, and then we'll just do standard character output x. And it's okay. We're not calling anything right now. Hold on. Well, it's not okay because one, we're not using this x yet. And if we call do thing like this, we get an issue because, oh, well, how do I fucking reference this x here? I can't do this x because there is no fucking x in, if we did in x, it's 3, and we could just say, well, I'm not going to do gx, I'm just going to do the same identifier. That way we can do x like this. Well, we're still going to get 1 here because, well, this one hides not only this x, but also this x. It's okay because we can still reference the global x, but we can't reference this outer local x. So it's being hidden. Cool. 40, ternary operator returns one value if the condition is true and another if false. i.e. and x is 3, or oops, what the fuck happened? i.e. and x is it's probably gonna have an issue here if we have if I have a constant guy. But let's just try. 3, if 3 is greater than 1, okay, it's gonna return 1, otherwise it's gonna return 2, like this. Oops. X is not being used. Oh, it's actually okay here. It doesn't care if this is, because it's not an if. If 3 is greater than 1. Yeah. If this is if const expression, but then if this isn't defined, then it's going to have an issue here. Yeah, exactly. Well, and this guy is within its own scope, so it doesn't even matter, but okay. i.e. and x is assigned the value of 3 is greater than 1, which is true. It's going to get 1, otherwise it's going to get 2. X is 1, x is 1 in this case, but would be 2 if 3 wasn't greater than 1. 39, pre-increment operator increments the unary operand before evaluating it, and post increment operator increments after evaluating. 38. Operator precedence rules determine the order that operators execute, i.e. y int x 3 times 2 plus this is 7 and not 9. This is because operator multiplication has higher precedence than operator addition. Associativity is the left/right order that operators evaluate. I.e., once we've sorted out precedence, we need to know how the statement reads. Like, if we have an x is 3 times 2 plus 1 minus 2 times 3 remainder 3. I mean, in this case, it doesn't matter. Maybe. We can split this up into 3 times 2 plus, hold on, plus something. We've got, fuck, is it 3 remainder 3? Fuck, I don't know if it's a multiplication or remainder first. I'm gonna say 2 times 3 remainder 3. I think it's that first. And then it's subtracting that plus 1. So I think it's this and then this. I think operator, this guy has precedence over operator remainder. So we've sorted out precedence. However, which direction does stuff happen? Do we add the remainder of 6 and 3 first? 3 before or after subtracting, or well, hold on. I mean, I don't think this matters because we know that we have a 6 and we know that we have a 0. So is it 1 minus 0 plus that? I mean, doesn't matter here since we have 6 plus 1 minus 6 remainder 3. It fits in 2 times with nothing left over at minus 0. If it did, do we subtract 0 from 1 first or add 1 to 6 then subtract? I think operator plus and operator minus are left to right. So we add 1 to 6 first, then subtract 0. I think. That doesn't matter for this arithmetic stuff, I think. 37. Standard string test, or well, standard string name, Ethan is an initialize standard string. You can print it or extract value to it via standard character input dot get line or standard get line, standard character input dot or to standard white space to ignore white spaces, leading white space, to name we can pass it to functions by creating a string view, assigning it a standard string view, assigning it the value of name, and passing it as an argument. That way the function views name's value and read only without having to expensively copy it. Const expression values, if used in context that requires them to be evaluated at compile time, are evaluated at compile time. Const values may be evaluated at compile time, but is subject to the compiler. If we need something to be evaluated at compile time, we ought to use const expression. That's all I've got for time. Cool. Nice. It's reading all the stuff. Okay, good. Expects a definition. Well, yeah. Yes. Not because without. Wait, hold on. As the entry point. So. Oh. So it's not declared anywhere. It's just. But isn't it declared? Isn't it somewhere? If I say an executable is a file and it has main at the top and it's expecting some shit to be popped in there, doesn't that mean main is declared? Like it exists, it just doesn't see definition. And for the linker to know that main exists, shouldn't it be declared? Isn't it? Doesn't it have to be? Oh, I didn't do a bedtime alarm. Okay. Let's go through these and then I'm gonna go to bed. You motherfucker. Okay, comments are ignored. Oh, well, yeah, I guess so. Okay. Well, yeah, we know that they're ignored by the compiler. Sure. Yeah, also true. They need to. Well, I mean, I did say they need to be used properly. So I mean, you got to use them for the start of a program. What the fuck is the program doing? You do it for some big block of text. What is it doing? How is it doing it? It's a random number. How is it getting it? Oh, it's using a PRNG. It's using a Merson twister. Oh, okay, cool. And then a standard seed sequence. Why are we using this? Oh, to avoid underseed in the Merson twister. Yeah, we're not doing anything super crazy. We're commenting exactly what we need. Cool. I can flay object and variable. Yeah, we know that not all objects are variables, but all variables are objects. Yeah, sure. Yeah, temporaries are objects. Yes. It can be named or unnamed. Well, yeah, it can be a named object, thus a variable, or an unnamed. Do you call it a temporary variable? I guess so, huh? Well, yeah, see, variables are, yeah, exactly. Temporaries aren't variables because it's unnamed. Yeah, exactly. Can be named, thus a variable, or unnamed, an unnamed object, thus not a variable. Int x is a declaration, indeed. And it's also a definition because it's saying where it is. It's just not saying what it gets. Yeah. I'm pretty sure I said that. Oh, well, okay. I didn't. This should say and definition. Yes, that's true. Initialization can occur in several forms. Yes, we know that it can. Yes, we have copy, list, value, direct list, direct, or copy list, direct, something like that. We got a bunch of, value already, copy, yeah, etc. But an output terminology is sloppy. Fuck. Extracts output from the input buffer. Well, extracts input. I shouldn't have said output. Extracts input from the input stream. Yeah, true. Yeah, I didn't mean to say output. I'm tired. Also, operator extracts. Yes, that's what I meant. I just used the wrong term. That was an accident. Some compilers might I give a variable a 0 or something value. No, not a something value. I give it a this value, because if we look at a standard string and I create it, I mean, if I go in, well, I'm not going to do it, but if we create a standard string and I don't do anything with it and then I print it, what do we get? We actually get empty quotes. We get nothing. Unless they're static or global, they're never 0 initialized by the compiler. Well, okay, so I guess it's the IDE, huh? I mean, we assume that it's a garbage value, which is why I say that we should assume that it is a garbage value. Well, yeah, with automatic duration, yeah, we know because it hasn't been initialized. For static, we know that it's value initialized. Yes, that's why it says unless static or global. Global is also 0 initialized. Okay, noted. Well, I mean, in this case, if I turned off warnings, what? Fuck. Well, I'm not going to turn warnings off, but every time I swear I've seen stuff and it ended up being 0. I swear. Well, yeah, because I'm looking in debug, and when something is declared, we're looking at it, and sometimes the value is 0. But sure, don't assume that it is. Yes, I'm aware. That's why I value initialize shit. I mean, look at any time I'm extracting input, I am value initializing the shit first. Well, it's not operator symbols, it's arithmetic ones. Style convention and also not universal. Yeah, it makes sense. Can't use a keyword. Can't use a keyword or existing identifier. What is redundant here? Can't use a keyword or an existing identifier. It's true. Are we saying that existing identifiers are keywords? I don't like that. I like keywords by being, keywords are data types or specific things that are already reserved by the language. An identifier is reserved by me or by whoever defined that shit. Somebody defined that shit. I don't think it's redundant. I disagree. Well, then how would you define or say that they can't contain usable operators? Oh, okay. Identifiers can't contain operator symbols? I disagree with that. I'm saying an operator is an operator. That's why we say operator plus, operator minus, operator times, operator remainder, operator division. It's an operator. Yeah, I'm not going to call it an operator symbol. It can't contain an operator. Hello? White space. It's ignored. So we should also say that it's ignored. Or, oh, yeah. So white space is ignored by the compiler, except when we're talking about. Oh, yeah. Because if we're talking preprocessor directives and I say define something as something, well, we can actually define it as blank and it gets replaced with blank. And it's not ignored in string character literals because it doesn't, if we have a space between it, it includes it or it ends the extraction of a character. God damn, this dude's ripping me. This is good learning here. Not sure how operators are relevant if we're talking about literals. The question about both. So you should just, God damn! Oh my god! Oh. Not sure how operators are relevant if we're talking about literals. It was about both. Motherfucker. Dude, you asked the question stupidly. Hey, holy shit, he's ripping me in half. Yo. Where? Oh, I didn't do control. Oops. 9. Yes, the values without initializers. Sure. If we're talking about literals. Yeah. And I did. Okay, so don't say that I'm not sure. Okay, fuck you, dude. Fuck you. Mostly correct, but you should clarify that all statements are not necessarily expressions. Well, yeah, duh. Expressions evaluate to result. A statement is an expression that ends in a semicolon, therefore it's an instruction. If it's just an expression, the compiler won't do shit unless it's an instruction. Duh. I don't know what that is. My explanation is rambling. Oh my god. What? Oh my god. Dude, he's writing it like a mean manager. Oh my god. Compiling the program will convert it. So what were you asking? You're asking how the programs, or how a C++ program is structured and how to do compilation. Bro, we write the source, it compiles, and and it links the function calls, and then it turns into binary, and then boom. Well, I guess in binary it finds the calls. Holy shit. Okay, so we write source code, then convert to binary, right? Then compile to binary to translate to binary, then linker links calls and definitions, then run executable. Run executable. Holy shit, I'm getting ripped. 59. Oh my god. Oh, holy shit. Okay. Yo. I like this. This is good, dude. This is mostly correct. We don't mention that they can also be evaluated at runtime. So I can say that it's only evaluated at compile time if used in a context that requires it. Therefore, it's evaluated at runtime in other contexts. Bro, this explicitly already includes that. Read between the lines. You repeat the same explanation as above. If called in a context, dude, this is fine. Okay, but say specifically when they can be used. Okay, buddy. No reading between the lines then. Okay. They return const expression values if called in the context where the value must be known at compile time, and they return non-const expression values if called at runtime, which they are depending on the parameters or depending on the use. Function templates. It asks about. Oh, here we go. Off topic. Oh my god. Bro, you said multiple template types. So if we're saying template types, we're talking about type name T and type name U. Okay. How do we call them? Bro, what are you saying? One, we do some template parameters, and we create them, and then I call them with either the same type or multiple types. It asks about. I should have said, give me some comprehensive answers too. Holy shit! It asks about state or response to include the same critiques verbatim, but also these suggested answers. Good. Rambling. Oh my god. You should clarify that they're required to be usable in constant expressions, but can also be okay. A constant expression function is a function that can be evaluated at compile time if its arguments are constant expressions. Well, can be, sure, but it also depends on what it's called within. If called with non, it will be evaluated at runtime. Well, it will also be evaluated at runtime even with constant expression arguments if called alone and not in a context that doesn't require it to become called at compile time. Suggested topic, a function can have multiple template type parameters, like this and this. So we can print that. And then we can print t, and we can print u. So allows the function to accept and operate on arguments of different types in the same function. Yeah, sure. Holy fuck. Okay. Reasonable answer? Well, it can be clear that templates are blueprints for functions and instantiated as needed for each unique type combination. Yeah, it makes sense. I don't know. I guess I rambled maybe. A function template is a blueprint for creating functions that work with any type. Compiler will generate a specific function for each unique set of arguments used in calls to the template. Holy shit. Okay. Unnecessary detail. Which wasn't asked. Oh my god. Well, I'm saying that numeric conversion makes them equally viable. Thus, they're ambiguous because of that. Function overloading allows multiple functions with the same name but different parameter types or counts, sure, and the compiler selects the appropriate function based on the arguments provided. Yeah, but I like providing the specifics of how those arguments are decided and in what combinations actually are actually ambiguous. Like, what happens if we do an int and a long? Well, is it ambiguous or is it not? If it's a non-type template parameter, yeah, it is ambiguous. You conflate auto for variables and function parameters. No, I'm using it in both cases. If you're saying regular auto type deduction, sure, I could have just mentioned it in a variable context or in an object constant, an object context. I mean, you could have said objects, not variables, bitch ass. Is only allowed in generic lambdas. Well, yes, in abbreviated function templates, which is exactly what I said. There's abbreviated function templates, yes. The auto keyword lets the compiler deduce the type of a variable from its initializer. Okay. Function parameters. Yeah, but you're not saying what it's doing in function parameters. What does it mean as a function parameter? Right, but your statement, type alias is probably cloud thing from help as a personal opinion, not a fact. Are you kidding me? Bro, it's literally a fact. Hello? Type aliases are widely used for clarity and to simplify complex types. Sure, if we're doing it for a complex type, okay, it makes sense. I don't know about templates. A type alias gives a new name to an existing type using or type def. For example, using distance as double, makes distance an alias for double. Useful for readability and managing. Yeah, but they can be fuckers too. Mostly correct, but it's confusing. The compiler will warn about narrowing conversions and list initialization, but not always prevent them. Well, I have errors treated or warnings treated as errors, so it will prevent them actually. Okay. A narrowing. What did I say about const expression variables? It's not. It shouldn't be unclear. If we use a const expression variable, like a const expression float, and we initialize an int, or well, let's say a const expression long, okay, and we initialize an int with it. Well, if we don't have a const expression long, then the compiler would say, hold on, long to int, narrowing conversion, no sir. But if we have a const expression long, then it will actually check the long and see, oh, it's not actually big enough to be narrowing, or, oh, it is big enough to be narrowing. When a value is converted to a type that can't represent all possible values, possibly calling data loss, this initialization will prevent them at compile time. Okay. Motherfucker, you just said not always prevent them, and then you said it prevents it at compile time. Fuck you. Mostly correct, but you should mention that all explicit conversions are done with casts. Oh, true. We do call them casts. We don't just call them explicit conversions. We say that they're used by cast. Explicit conversion is in the compiler, or implicit is when it automatically converts one type to another. But you didn't say when it's doing it. When does it do it? Why does it do it? I say it's when it expects a certain type, but it's not given that type. Explicit conversion is when you manually convert between types using a cast, like static cast. Okay, gotcha. Holy shit, focus on the distinction. Assert is runtime static, assert is compile time. Assert, expression, checks a condition. Makes sense. And then expression, you should do and message. the logical and to combine the message in that. Unless that also works, I don't know. Or I guess it just evaluates the left operand, huh? Or no, doesn't it disregard it? I don't remember. I think it does. Checks the condition at compile time and causes a compilation error if false. Overly verbose. Holy shit. Of course, check standard character input. Well, I'm not going to do fail. I'm just going to do standard character input. It's more concise. Clear the error state and invalid input. And then I can also check for extraneous. So you don't care about extraneous? Okie doke. Alright, buddy. Correct, but you can mention that code coverage tools measure which lines or branches of code are executed by tests. Code coverage is the proportion that is executed by your test. Higher code coverage. Yeah, that's exactly what I said. Take correct. Motherfucker, what? Break exits to the nearest enclosing loop or switch statement. Continue skips the rest. Technically correct, but verbose. Mention Merchant Twister is the engine seeded for randomness distributions. That's exactly what I said. In modern C++, use that, seed it with a random value, and use a distribution like that to generate numbers in a specific range from the Merchant Twister. You don't just use it to generate the numbers. Correct, but you ramble. Oh my god. Focus on switches for discrete values if it's for ranges conditions. Okay. Switch statement selects among the multiple possible code paths based on the value. Use switch for discrete values and if statements for ranges. Okay. It is called the for statement or for header. Okay. While loop checks before, the do while checks after, and then the for. Yep, and then the for is for known stuff. Okay, gotcha. Group of statements, closed and braces. Also, I didn't say that for the syntax. I need to do that. Create a new scope for variables. We can group statements together so they're executed sequentially. Cool. Sharing global constants. Yeah, inline const expression. Share them. Inline const expression. Cool. Multiple definition. Same treatment. Oh my god, if you want the same treatment, man. She is busting me down. Holy shit, dude. Woof. Okie dokie. It's time to upload. That's it. I gotta go to bed. Took an extra 20 minutes, but I am down. Holy crap, I got ripped on. Okay. Or tomorrow. Tomorrow I'm gonna do some crazy shit. So I'm gonna do timers. I'm gonna wake up, set my timer for like an hour, get my shit together, and then fucking start. Hour and a half, hour off. Hour and a half, or hour and a half, half an hour off. Hour and a half an hour off. Hour and a half an hour off until I don't know. I don't know what the strat is. I mean, 3 hours a day sure is pretty good. I mean, 3 hours times 365. I mean, what, we've got like 1080-ish or something like that? Yeah, about 1080, 1095, I think, maybe is the math. Yeah, isn't that it? 1095 divided by 3. 1095 divided by 3. Cool, yeah. So, I mean, it's 1,095 hours, but, and so it's basically the same amount of time as a 4-hour workday 5 days a week, but I mean 1,000 hours. That's 1,100 hours in a year. I mean, it'd be cool if I could do more than that, because then we could say if there's 52 weeks and we're doing 3 times 5, we're doing 15, but then we're doing 6 and 6. So it's 12 and 15. I'm almost doing all the same work. I'm doing 4 days of work on the weekend and then 5 days of work on the weekdays. That way, if I've got 15, or hold on, isn't that it, right? 6 and 6, so we've got 12 plus 15. Really? 27? And then if I do 27 times 52, oh wait, really? That's it? If it's 27, oh, the problem is I'm only doing 3 more. So it's like 30% more, I guess, right? 1095 divided by, right? 1095 divided by 1,400. So it's like 22% more if I do harder weekends. A 22% increase though. Oh fuck. I'll do it and feel it out. I want to see. I mean, I like locking in for a while and then chilling for the rest, but I don't know. I'm going to try and go hard tomorrow and we'll see. And it's still only 6 hours too. I mean, fuck. Could just lock in and go all. Hour and a half, half an hour off. 2 hours, and I could do probably 5 of those, or I could do, hold on, there's 8 of those really in the day, but I could do, let's just say 6 of those, and that's 6 times an hour and a half, which is 9 hours, and that's 9 and 9, that's 18. So I'm doing more work on the weekends than the entire week. It's 9, and then I could do 3 hours of testing and 6 hours of learning. So it's 4 hour and a half sections of learning, and then but that's also so much time to, fuck. I don't know. Excuse me. Maybe it's enough, maybe not. I don't know. I'll feel it out tomorrow, I guess.